Welcome, everybody, to another episode of Pirates Only. And today we have a very special episode on data centers, which on the surface may not seem that exciting. But as we go into in this episode, data centers are one of the most important pieces as it relates to the AI revolution that is happening right now and will continue to happen and accelerate into the future. I'm joined by Philip and Sam. Philip is the CEO of StarCloud. Sam, the CEO of Network Ocean. Both of them Y Combinator companies in the same batch, and we touched a little bit about that. But they're taking on this challenge from two different angles. Sam is building data centers both on the ocean, on barges, and then also underneath the ocean, on the ocean floor, while Philip is taking the approach to space, building data centers in space. And we talk about the advantages and the difficulties of building in both. But we come to the conclusion that we're not going to have enough data centers. We got to start building them everywhere. So don't miss this one if you are excited to learn more about not just data centers, but the future of AI, humanoids. We go into a bunch of different topics. And as always, if you are a deep tech founder, if you're building in data centers or AI or any of the critical technologies that we deem imperative to national security, we think that you should apply to Black Flag. Black Flag is an accelerator from Harpoon Ventures where you can apply and receive not only a check, $250K to $1 million plus, but hands-on support as it relates to government relations, go-to-market strategy, design, branding, and everything that you will need to go from 0 to 1 with your startup. So apply today at blackflag.vc. Let's get on to the episode.
Hoist the black flag high, let the cables hum. Code and cannon ready, futures beating like a drum. Charts are drawn in circuits, treasure maps and AI. We're sailing for the edge where bold ideas never die.
Welcome, everybody. I am joined here by Philip and Sam, and we're here to talk a little bit about the data center revolution, I think is maybe the right way of calling it. I feel like a day without hearing about the importance in building out our data center infrastructure and how that touches on to everything from AI and energy. And we'll probably cover a lot of that in this episode. But let's start with some introductions. Sam, lead us away with who you are and what you're building.
Yeah, well, I'm Sam, CEO, co-founder of Network Ocean, and we build these underwater and floating barge data centers. And this is primarily so we can take advantage of free seawater cooling, and we can be much more power, water, and cost efficient for specifically these GPU data centers.
Love it. Philip, over to you.
Yeah, I'm Philip. I'm the co-founder and CEO of StarCloud, and we're building data centers in space, initially to serve other satellites with compute, and then later to sort of address the AI energy challenge by drawing enormous amounts of power from solar and space.
Fantastic. And you guys were both Y Combinator companies, and we just covered that you were at the same batch together. So that's exciting as well.
We were. There's one thing I remember about Sam, I hope he doesn't mind me saying. I think it was either you or your co-founder who on the first day, he wore this was it you that wore this need GPUs t-shirt? Was that?
Yeah, that was my co-founder. So he went all out.
He stuck this sign to him that said "Need GPUs?" and was walking
I
around
love
the
it. I love
I
it.
was like, this is hustle. This man has hustle.
That's fantastic. I think going into an accelerator and kind of going through that program, I think the relationships you build out from it is great. And I think it's also great when you have other partners or other founders that are building in a similar space. And so this conversation, I think, is kind of a cool a combination of that as well. I'd love to maybe dive a little bit deeper, Sam, into the ocean in this case, on what specifically led you to wanting to build data centers in the ocean versus maybe on land. And we kind of start from even maybe taking a step back of why data centers in general. What brought you to wanting to start this?
Yeah, that's a good question. So I'll give a little personal background. I've been obsessed with ocean infrastructure specifically since I was in middle school. So this really started on the power side where I was building these underwater generators. These were MHD generators that would operate in ocean currents with no moving parts. So that was the big goal. It was very prototypey, very researchy. But essentially I was just driven by my definition of impact, which is maybe different than the colloquial definition, but it's doing something that's not necessarily going to happen unless you're the one that pushes it. And it kept kept getting driven towards the ocean opportunity just being like absolutely massive. And we were just at the time really regulated to, low power devices, everything out in the ocean. So my real goal was trying to evaluate what scale technology is run better in the oceans than on land. And I was looking at, a ton of these different possibilities there. Even back in 2015, there was, Microsoft that had these experiments with their own underwater data centers. And at the time, I'm like, this is it. This is going to bring the demand. All I just have to focus on is the power out there. But, that didn't really pan out. And for a few reasons we can get into later, essentially it was until, 3 years ago when, this demand inside the power density inside of these data centers just absolutely skyrocketed. Traditionally we're fine with air-cooled systems. Now you need liquid cooling. All the emphasis is put on this cooling system, and current infrastructure is not like nowhere near efficient from, power consumption, water consumption, and just the capex cost of building this thing out. So, around a year and a half ago is when we started building this. Yeah, I mean, that's where we are. It was, the first time where it was economically viable to build these things at scale. And obviously it's, just like in space, it's a harsh environment. There's lots of things to figure out, but it was definitely the first time where, you can start building out this infrastructure that would enable huge capability off of it.
We had an episode earlier on Pirates Only where we talked about just building in the ocean being really, really difficult. And there was a little bit of a rivalry going on, and that building in the ocean is actually harder than building in space, and that salt is actually harder to do. We won't try to ruffle any feathers here to make that argument, but at least can understand that building in the ocean is very, very difficult, and it adds a whole other layer on top of it. So the benefits, we'll go into maybe some of those differences a little bit later. Maybe as a quick kind of summary, how big is the team? Have you raised any capital? You mentioned going through Y Combinator, and you said how many years have you been building through it? Just some of the basic questions there.
Yeah, just around a year and a half, maybe a little bit over that. We're based in San Francisco. We have 5 people on the team and a bunch of
Nice.
expert contractors that we use, part-time here and there. We've raised around 2.5 million to date.
That's awesome. That's awesome. Philip, kind of the same question over to you. What led you into data centers in general? And then maybe what caused you to try to go up into orbit instead of trying to build them here on Earth?
Yeah, for sure. So my background, spent the first 5 years of my career on the engineering side, and then went to moved to the commercial side of things. So spent some time with McKinsey working with the space agencies of various governments. And I think that's where I noticed the very rapidly declining launch cost was enabling lots of different things to become possible that were not previously possible. One of those that we started looking at, so I went down to Starbase Texas in early 2023 just to have a look around. I was like blown away by the scale of what they're building in terms of both the future reduction in launch cost and the future increase in capacity, which is potentially we might get 100x reduction in launch cost, and we might get a 10,000x increase in launch capacity, as in total mass to orbit per year. And that's because starships compound on each other. If you build one Falcon 9 every day for a year, at the end of the year you have one Falcon 9. If you build one Starship every day for a year, at the end of the year you have 365 Starships. And they're building a factory that can produce 3 Starships a day. It's absolutely mind-blowing. But anyway, so we started looking at space-based solar, which is not a new concept. That was around in the 70s, people were talking about this. And the whole thing is just a calculation on the launch cost equation. So we ran the numbers and said, okay, what would the launch cost need to be for space-based solar to make sense? The number we came to is around $50 a kilo. And that assumes that you have a 95% efficiency loss, or 90 to 95% efficiency loss getting power from space to Earth, because you're using microwave or laser technology to beam the power down. Then we were looking at, okay, well, all new terrestrial energy projects are being built basically for data centers. So let's rerun the calculation, assuming we had a cheap way to get the data center to space. What would the launch costs need to be for us to be competitive with terrestrial energy costs, including the launch cost? And the number we came to when we reran that calculation was around $400 or $500 a kilo. And so that was the basis of a white paper we put together. And my co-founder Ezra and I grew up in the same place in the UK. And then he has a PhD in engineering and spent the last decade building satellites. Most recently with Airbus Defence and Space, working on NASA's Lunar Pathfinder mission. And then my third co-founder Adi was at SpaceX as a principal software engineer working on Starlink. And before that, 20 years at Microsoft on the data center side. So basically, we put together this white paper, and that was the genesis of getting going on it.
I love it. Maybe we kind of double click into both of the technical aspects of it. Could you explain maybe why building in space or in that environment
does actually produce a more efficient transfer of power or energy. And then we'll go into some of the reasons why it's so critical for us to try to hit these numbers. But maybe just explain for some of the audience folks to understand the benefits of building in space.
Yeah, for sure. I mean, maybe I can illustrate it with a full Starship payload bay of compute chips and solar panels and radiators. So one full Starship payload bay is about 100 tons. This is, and by the way, I should say that the initial business we're starting with is serving other satellites that need edge compute, let's say. And for that, we can do it with the Falcon 9 launch cost. But if we're going to compete with terrestrial data centers, we do need Starship launch costs. So one full Starship payload bay, 100 tons. It's what we expect it to be about a 40 megawatt data center. So including the chips, solar panels, radiators, and satellite structure, we expect to be able to fit 40 megawatts in one full Starship payload bay. If you run, the chips are going to last about 4 years. So if you run that terrestrially for 4 years, then and let's say you're paying 10 cents per kilowatt hour, which is, for a new energy project is pretty standard. Your energy cost alone over that 4 years is $140 million. Versus what we're doing, you can launch it for potentially as low as $10 million, maybe $5 million at the $50 a kilo mark. Your solar panels are about another $5 million, and then all of the other costs are roughly netting out. So the cost of the coolant loops is similar, the cost of the chips is similar. And so rather than $140 million on energy terrestrially, you've got $10 or $15 million for launch and solar. And the real advantage is you can then scale it almost indefinitely with no permitting cycle. So if you want to build a 200 megawatt let's say you want to build 200 megawatt data center terrestrially, like you're looking at a 10-year lead time on that, building that energy project in terms of permitting. You can launch 5 of these 40 megawatt modules very rapidly within a month, locate them physically in the same place or the same orbit in space, and then be up and running within a month with a 200 megawatt data center. And you don't have to stop there. You can scale that to multiple gigawatts. So we started it about a year and a half ago as well, January last year. We're 10 employees, raised a $21 million seed in September and October last year. And before that, did a $2.5 million pre-seed, $23.5 million total so far.
Congrats. That's awesome.
And effects like that.
So kind of staying on the space really quick, and then we'll go on the ocean side. I never thought of the benefit, at least one of the benefits being that the scalability of it and the lack of regulation and those types of things. I think that's pretty incredible. At a high level, is it fair to say, I guess right now, are you saying that today's product is essentially being a data center to the objects that are already in space? Is that kind of the best way to think about it?
Yes.
And then as costs get lower for you to be able to then be a data center for the objects that are terrestrial and on Earth.
Yes.
I love that. That's awesome. That's it's such a first principle way of thinking about it and building it up too, where you can service. My guess is the demand for space compute is also still high and growing as well. So even that alone being a business is a great place to be.
It is. It is growing incredibly fast just because of the launch costs having come down so rapidly and the number of objects that collect data in space going up so rapidly. So, yeah.
Sam, kind of the same question on your side. Can you talk, I guess that cooling temperature, there's probably a lot of benefits there, but can you give some specific examples of why building these data centers at the bottom of the ocean is the better alternative than on Earth or on the surface?
Yeah, absolutely. So, I guess to caveat this too, we have 2 of these units. One are these underwater vessels that sit on the seabed, and it's typically, these are near shore. Both of these are typically at industrial waterfronts, so like ports, shipyards, places that have accessibility and large power infrastructure already. So this is, typically where we operate. The main focus for us right now is deploying our actual pilot unit, which is a barge, a 200 kilowatt data center barge. So it's a floating platform with the data center on top of it, and we get free liquid cooling underwater. It's much easier on a few of these different sides, namely maintenance and scalability and, being able to operate it like a normal data center.
Salt water.
Yeah. But we still get the same advantages of cooling. And that's like honestly the most straightforward answer here. It's operating the oceans. You do have a lot of space, but the biggest thing is you have the largest heat sink you can get. So that's where we can operate. Our first unit is this 200 kilowatt unit with some GPUs. And it's pretty clear to see all in the cost benefits compared to these like on land GPU specific data centers. And we'll scale from there.
So explain to me again. So what's on the barge versus what's on the bottom of the ocean there? So what's the separation technically?
Yeah, so for the underwater vessels, they're like pressure vessels. They're, essentially like these submarine capsules that sit there. They're housed with a bunch of compute cooling systems. A lot of it is passively cooled through the shell of the actual vessel and some heat exchangers on the outside of the vessel. But you can supplement it if need be, which usually you don't need to, but with an active cooling system where you pump seawater. It's nowhere touching the chips. There's separate cooling loops. You have a closed loop cooling system for your hardware, and then you essentially reject the heat into the seawater. And it's a similar system for the floating, except, I mean, obviously it's at the surface. It's usually sitting at a berth. You can plug in with power, with internet, operate like a normal data center, and we get free cooling in a similar manner. So to like shed like a little background on, if some of the viewers are not like super aware of what normal data centers look like on land for these new AI data centers, around a third of the entire build out of the data center in terms of space and in cost of the facility is cooling. So there's these massive cooling towers, evaporative chillers, large pumping systems that you need to actually reject the heat. So there's, systems that, take the heat away from the chip itself, and then like move that somewhere else. And then you need to reject that heat out of the facility. So instead of those massive, cooling towers, evaporative chillers that are very, water inefficient, some of these other systems that are very power inefficient, they're all very expensive as well. So for us, we can eliminate a lot of that and make it just a much simpler cooling system by building some of these seawater components.
Do you have an idea of like from the cost in energy like consumption that those like on land, like is it equal cost saving, I guess, in a way, or can you talk a little bit about that?
Versus floating and underwater, or versus?
Yes, exactly. Like you mentioned, I mean, the size disparity, or at least being able to split out the size and have the cooling piece at the bottom of the ocean versus on land. But my guess is that the energy cost for the cooling systems of those massive, or the energy for the massive cooling systems has got to be huge. And do you have an idea, I guess, what the cost savings or differential is specifically
Yeah.
on one of your data centers versus an equal sized one on land?
Yeah, good question. So I guess the main metric in the industry is PUE. So this is like basically how power efficient is your facility, and mainly this hinges on the cooling system by and large. So industry average for a while has been 1.5 or 1.4, 1.5, something like that. Some of them are cutting that down a little bit, but essentially this means that if you're powering all of your servers with 1 unit of compute, you need half of that more to run all like essentially the cooling system and the rest of the components in the facility. And so for underwater unit in early tests, we've seen a PUE of 1.07, which drastically cuts down this entire power usage of the data center. And a lot of those savings are just, for us, passed on to the customer, and we just want to scale this out.
That's incredible. I love it. Philip, I know you mentioned, I mean, one of the big benefits being the ability to easily scale. Are there any other additional benefits that you want to touch on from the space side?
Yeah, I mean, in the longer term, so in the short term, cooling in space is actually quite a challenge because it's a vacuum, and so you need to build very large deployable radiators, which are going to emit this heat and infrared out into the vacuum of space. In the longer term, if we double or let's say we 10x the total amount of power that we're using currently, either on data centers or in general, there comes a point somewhere between about 10x and 100x where the amount of heat that we're kicking off from these data centers and just in general from power usage is enough to warm the planet itself. So if you're using fusion reactors, for example, or if you're using any other power source, you're just, we hope fusion reactors work, but you're literally just pumping heat out into the atmosphere. So it's not necessarily from fossil fuels; it's just literally from the waste heat. And that there comes a point where that is actually prohibitive to scale any further. And it's within our lifetimes. So between 10x and 100x is probably within our lifetimes. And at that point, the only place you can build more data centers is in space, because that's the only place you can push more heat out into the vacuum of space. So in the longer term, that is one advantage of space. We've got a little way till we get there, but it's coming quicker than we think, I think.
Yeah, we'll dive in a little bit on some of the demand, and I'm sure that you guys are seeing even from your own pitch decks and thinking about it. But we'll dive into that. One of the other questions that people were interested in related to each of your businesses is diving in specifically to some of the difficulties of what it means. Maybe sticking with you, Philip, on building in space. You have the additional capex of actually like getting into orbit and doing all those things. What are some of the other difficulties in thinking about, building a data center in space and the technicalities that go along with that, maybe a typical startup that's not building in space, but certainly maybe not a typical data center?
Yeah, I mean, I'd say half the team is working on this problem I just described, which is the cooling problem. So half the team is building very large, low cost and low mass deployable radiators. The other half of the team is working on making chips work in a high radiation environment, or working to mitigate that through shielding or through algorithms. So yeah, those are the two big engineering challenges for us: is thermal management and radiation shielding.
It's funny, it's like radiation in space, and then it's salt water in the ocean. Sam, kind of the same question over to you. What are some of the difficulties of building in the ocean that maybe some other founders may not realize?
Yeah, pretty similar. There's two. There's corrosion from the seawater, and then there's biofouling. So things in the ocean just like to grow on things. It makes it a lot less efficient. They eat into a lot of what you build out there. So those are two main challenges. There's a few others. I think by and large, they're relatively solved problems. Just in like the marine industry is there's a cost and maintenance cycle that you have to follow and to implement and build these things.
The regulation an issue? That was something that was brought up as well. Was the regulations in space sound like those are a little bit lighter, but regulation in the ocean tends to get difficult. Certainly, as it relates to mining, energy production, those types of things. Obviously, different industry in what you're doing. But is regulation going to be a friction point or something that could prevent or hurt you as you keep going?
Yeah, that's a really good question. And I think one thing is it's very different from location to location, but it's also like it lines up pretty nicely with the locations we look at, especially this industrial waterfront. So a lot of these, ports, shipyards, places like that, because there are typically very dirty things around there, and there's plenty of unused space. So as a comparison, there's ferry ships, cargo ships, cruise ships that are, all they have engines that are actually, super high power and liquid cooled in a similar manner, multiples higher than the heat that we would dissipate with our facilities. So it's quite easier to make that comparison early, and there's definitely some differences, and it's slightly quicker than actually deploying a full data center of similar size on land. So it's pretty interesting from that.
Yeah, and my guess is that it's not like you're putting these on like pristine coral reefs. Like there's not like you're trying or even put these in the middle of the ocean where there's no infrastructure already in place. If you can put those, to your point, in some of these areas that are already habited by machinery and that there's already disturbance, I guess, going on from the ecosystem level. By you adding on to that, it's not that you're doing additional harm, so to speak, or any harm, but because it's already so busy in those areas, it's not that you're at any risk in doing anything there.
Correct. Yeah, I mean, one thing is like there's also like a temperature gradient that you look at from the
Yeah.
temperature you get the water in at the coldest point, and then the hottest that you outtake. And for us, it's with within a few degrees Fahrenheit, and obviously in water it dissipates heat really fast, very high specific heat capacity as well. So I mean, obviously there's tons of testing and surveys that we're doing, but yeah, everything that looks pretty good for now.
From like just like a maybe a little bit more boring kind of level, but how do you have to go down and like scrape and clean them off, or like what does the process like actually look like in keeping some of these clean and maintaining them? I don't know, at a high level, maybe give it like a range of time of how often you'd have to go and maintain them and how long they would last down there.
Yeah, good question. Good question. So underwater is the more interesting one. I'll start with the floating version. The floating barge is, fairly similar. These things operate for decades, and they're very commonplace. And essentially, for our pilot, for sense of scale, it's roughly two of these ship containers worth of equipment on our end that's sitting berthed on this barge at a port or industrial waterfront. The underwater is so that's like much easier to do maintenance. And the big thing to consider is that, especially working with these GPUs, there is a very high failure rate of the chips themselves. Right? So networking equipment chips themselves, and you need someone there to actually make these switches to get these things back online. So that's a big reason why our main focus for the pilot is these floating units. It's much harder to do that underwater. So you have to just bake in this, whole kind of maintenance operation, which has to happen fairly frequently. So the operation with that is, you're looking at how many chips go down. At a certain point, it makes sense to let's do the switch. So you float it back up to the surface, and typically we're in shallow waters, like also at industrial waterfront. And then we take it on land, we do the switch out, the fixes, and then we put it back underwater. So it's it's an interesting thing that we're looking into. It's kind of similar where the large scale demand is definitely something we can attack with those floating data centers. And there's some of these like niche markets where underwater definitely makes a lot more sense. And in the longer term, like I don't have high conviction that this will happen in the next few generations of chips, but we'll continuously monitor if the failure rates of these chips start getting, much better. There's also some very interesting research going on with, these underwater data centers, and Microsoft's early experiments, back in 2015, 2016. They had 1/8 of the failure rate of their servers in those underwater capsules. So, that is theorized to be because of, it's a very sealed, clean environment. They also, actually use nitrogen and, some other, kinds of gases for a lights out data center instead of needing normal corrosive oxygen. So there's some interesting experiments we're doing on that front, but by and large, our full focus is for the scaled floating facilities.
That's incredible. Philip, you mentioned on the radiation side, kind of a similar question. Maintaining those and continuing to do that, is it in space? Is it typically that you're launching these objects up? Is there a maintenance process, or are they just coming down and you're just like relaunching up? Or what does the process look like of maintaining your product in space for you guys?
That's a great question. So initially, we will not have access to them, and so it's a bit like any satellite, like the Starlink satellites or any others, where the critical systems will have to have redundancy, and then we will have over provision on things which will degrade over time, like the solar panels. Over time, the industry is moving towards robotic maintenance, and so over time, I'm expecting within 5 years, pretty significant and substantial robotic maintenance operations in space. In fact,
Yeah.
one sort of interesting sci-fi concept is I expect within 5 years, probably we're going to see terrestrial data centers being maintained with humanoid robots. And humanoid robots actually surprisingly work pretty well in space if you put them in a spacesuit. That takes care of radiation and thermal. So it sounds a little bit sci-fi, but we could see humanoid robots maintaining space data centers at some point.
I mean, it doesn't. I don't think it sounds too sci-fi at all. I think it's a no-brainer. And one of the questions I was going to ask was, what
I'm
other
glad.
companies? Yeah, exactly. What other companies do you know of that are, I guess, operating or helping companies like yours in space right now from like a support level? Because I feel like that's a whole other industry you're providing right now, the data center and those pieces to the space economy. But there's so many other pieces in the space economy that are going to start emerging. And I think that's just one of them. I don't know if you have any others top of mind that you're thinking through that could be exciting as well.
Yeah, I mean, there's tons of robotic maintenance and maintenance companies coming up. Starfish Space a month ago just
That's right.
launched their second spacecraft. I think they'll do the first commercial space rendezvous and docking. Then in our batch, there was one called Spacium, and they're doing space, in space refueling. I think there's going to be a whole bunch of these.
Yeah, that's the space economy is the ocean economy and space economy. Both I think are going to be incredible to watch over the next decade or so. Which kind of brings into the next phase of conversation here. It's a fun one. Like I mentioned earlier, I feel like I don't go a single day where data center isn't a topic of conversation. I hear it from folks on the Capitol Hill side and the political side as it relates to how do we start thinking about data centers? How do we think about regulation and the size and the energy consumption? And it's always in this weird conversation of we need way more of them, but we also don't have the energy to supply way more of them. And there's this balance and chicken and egg thing. Then meanwhile, we have an incredible surge in demand over the last a couple years, certainly. But if you look over the last even 5, 10 years, it's almost exponential, and it's continuing to go that way. Maybe Philip, staying with you, could you talk a little bit about what you're seeing from a demand side? I mean, probably a lot of the same conversations that you would have with your investors on why what you're building is so critical, and what the demand is going to look like projecting forward over the next 10 years or so.
Yeah, for sure. And I'll just quickly touch on it because you mentioned the Capitol Hill conversations. So we had a representative from Senator Round's office reach out saying he's very interested. And so we went to meet him in DC, my co-founder Ezra and I. And he views it as a national security priority that we find massive ways to get to generate massive amounts of new energy to power AI data centers. Purely because places, in China, for example, they're deploying enormous amounts of solar energy mainly to power data centers. And if the future of national security is on who has the best AI, then that is certainly of course for the US government to be concerned about. So, but in terms of the other demand, the first bucket of demand is coming from other satellite users. And to be frank, in the initial stages, that's the conversations we're mainly having are with DoD customers, and they have lots of programs to fund R&D upfront. So we're partnering with them, and we'll be running some demonstration customer workloads with them on the first satellite that's going up next month. In the later stages, we'll be partnering with large data center builders terrestrially, and we're hopefully going to sign an MOU with one of the largest data center builders. I won't say who it is, for energy offtake. So yeah, that's where things are going in the end state.
Could you explain, maybe dive a little deeper on the conversations that you were having in Capitol Hill? You mentioned national security issues, which I think a lot of folks would agree with. What particularly is it? Is it simply that we're trying to geopolitically compete with China and what they're doing, and if AI is considered there? But is it also, a lot of the conversations I have as it relates to that is that just the infrastructure required in order to build that, maintain that, is also kind of at a national security risk. If we need to continue to progress on the AI side, we're going to need more data centers, and we want more data centers. We're going to need more energy production. Was there any more like conversation on how they were explaining as they're thinking through the industries around data centers that also I think need to be updated dramatically over the next decade?
Yeah, 100%. I mean, you hit the nail on the head with the need to build huge new energy projects. And the thinking mostly has been we need to speed up regulation. We need to speed up permitting cycles for things like nuclear. But as people are starting to look for more, for new and innovative ways, they're starting to think, okay, maybe there's something to this building huge data centers in space. And I think Eric Schmidt recently was giving a testimony on Capitol Hill, and he said, the demand for energy is going to go up by some crazy number. And later he was asked about that, and he recently bought Relativity Space, a launch vehicle company, and he said that the reason he bought Relativity Space was to build large data centers in space, which is I thought was very telling, because he's one of the people that knows the most about it, given his time at Google.
Yep. It's I think the whole space is going to be in for a wild ride. We'll share some charts and numbers, but when you look at the growth of data center demand, it's almost like this weird inflection point that obviously hit around, right when AI and ChatGPT and started growing, but then it gets like more and more steep as we continue to grow through. It's like it's not a once we get to like 2029 and then 2030, it just continues to go up higher and higher.
Exactly. Yeah, I sometimes get asked, well, why can't we just do this terrestrially? And my answer is basically, if I thought that we were going to double data center energy consumption over the next 5 years and then it was going to stop growing, I would say, okay, it's an enormous effort to build data centers in space. Let's just figure it out terrestrially. That's not what's going to happen. It's going to double over the next 5 years, and then it's going to quadruple over the 5 years after that, and then it's going to 8 times over the 5 years after that, and it's just going to keep going and going and going and going.
Yep.
There's basically no end in sight.
Yeah. Sam, kind of the same question on your side. Are you seeing and feeling some of that demand as you were going through the fundraising process and talking with customers now? What does that kind of pull, whether it's geopolitically, politically, revenue side, whatever it might be that you're seeing from that?
Yeah, absolutely. I mean, of course, there's like unprecedented demand for us, like with our pilot unit. It's mainly for these like neo cloud type companies. So GPU specific clouds that, liquid cooled data center space, to cool these next gen chips are super in constraint right now. It's pretty much like, not only can we build this and offer this for you, but it's much more cost efficient, power efficient, water efficient, on all those fronts. They can expect to save somewhere between 20 and 30%, using our kind of barges versus these online data centers. Quite significant demand. And I think just like to put the actual scale in perspective, I grew up in a like local IT family business, right? So I was like setting up some of these servers into like small and local businesses. That server was maybe takes like 100 watts or so of power. Maybe the whole rack, if it's filled, is like 5 kilowatts or something like that. I mean, now like with NVIDIA's NVL72s, we're looking at like 120, 130 kilowatt racks now. And this is like only projected to increase in density like crazy, right? So 600 kilowatts soon, megawatt rack soon, and it'll just keep increasing. So I mean, on the usage side, I mean, there's these massive training clusters that are set up, and we're really just starting to see like this inference demand start to scale, right? So, I mean, there's no question in mind we're going to have over a billion people using these, billions of people using these AI tools, and billions of agents going around as well. So the inference demand is just going to be insane, and we have to build that. And for us, it's obviously like we have to get there as soon as possible, so we can build this infrastructure much more efficiently than what's currently out there. So there's a race internally in the team to get this going. Every time we see a new headline for a massive data center being built, we're like, we need to be there. That every second we're waiting here, there's another data center that's going up that could have been built much more efficiently.
Could either of you maybe shed a little bit of light on, for the folks that don't understand necessarily why or how the demand is growing so quickly? Obviously, AI being a big piece to that. But Philip, you kind of mentioned it, which is true. It's like we need to double by 2030, quadruple by 2035, and then 8 times, and then 10 times, and then it's going to grow and grow. Why is it that we're seeing like that type of growth? I don't know if you could add or shed some light uh, on why AI is like so power consumptive, and what we're going to be doing, and we'll project this into maybe what the world looks like in when those things become a reality. But do you have any kind of clarity you can add to folks who maybe don't understand why the demand is just getting so high? Like what are we getting
Yeah.
out of that?
Yeah, yeah. I mean, a very crude and simple way of looking at it is that people are writing more ChatGPT queries, and each ChatGPT query uses an enormous amount of energy. A more nuanced and accurate description is that the world is and will be populated with agents, AI agents doing lots of things. AI agents are basically almost continuously running inference queries on these models, and they just go back to back to back. They one query that leads to another query, leads to another query, and it leads to another one, and they can essentially replace human workers. So then the question is, how many workers do you want? And the answer lots of companies are coming to is an absolute shitload of workers of these AI agents. And when you say what's the most number of like digital workers you could use, oftentimes the answer is there is no upper limit in the number of sort of very low cost digital workers I could use. And so that is essentially, I think, the key driver of it, because each one uses just an enormous amount of power.
Yeah, I think when I've asked people that before, and I get the answer of like, well, it's just more and more people that are going to start using AI, and they look at it as almost like a Google search, where it's like, well, more people are going to start asking ChatGPT questions. But you're exactly right. I think the AI agent side is going to continue to compound, and people don't realize that you ask an agent to do something. What the agents are doing now is like replicating themselves. So it's like I'm going to replicate myself as an agent 4 times, and then that agent's going to be able to replicate themselves to handle specific tasks, and it breaks down into this massive, for maybe one query, like you may ask it one thing, and it ends up breaking off into this chain effect of all these different AI agents running. And maybe another kind of question: have we, in your guys' opinion, are we limited today? Like, is there where's the chicken and egg, cat and mouse type of effect of progress in AI as it's related to the energy consumption, the chips that we're trying to put in these data centers? Like, are there, what are the blockers today? It feels like they're all kind of leveled up, but they're all, leveling up kind of at the same time. But which one is going to be the blocker? Like, all of a sudden, are we going to hit AGI? And then now all of a sudden, AGI is limited because of the fact that we don't have the energy to run AGI for everybody yet. Like, where does do the limits kind of come in?
I can talk my own book if you want.
Please, no,
Go for
Phil,
it, go
go
for it.
ahead.
I mean, yeah, without too obviously talking my own book, I do think the fundamental limit is in energy. I mean, that to me does sound like the fundamental limit. So, but I mean, that is also the problem we're solving.
Exactly right. Yep. So I
Yeah,
think if you
yeah.
can, yeah, go ahead, Sam.
Yeah, I think off of there, a lot of the capabilities that current AI models have shown, past these thresholds of economic viability. We've already seen this in multiple industries. I think that the next step are, actual breakthroughs in scientific discovery. I think that's, super, super exciting and game changing in terms of, like human understanding, human capability. But, in terms of like more short-term build outs, it seems like most of these main hurdles have been crossed, but a main limiter definitely seems to be, power and financing, right? So
Yeah.
like these data center facilities facilities are incredibly expensive, and we've already been tapping, like at least started to tap some of these, large pools of money. But I think that'll continue to grow for sure. Cooling is definitely a thing. You can't use air cooled data centers. These are getting incredibly more dense. You need to look at new cooling technologies. I think there's like some very cool technologies coming kind of across the stack to make that work down to the chip level, all the way to the facility level. And then on the power side with nuclear power coming online, it'll be exciting to see what happens.
That'll be fun as those things unlock. Hopefully, it unlocks companies like yourselves where you end up feeling like you have unlimited power to continue to scale and grow through. And I think that we'll meet the demand. I get the question asked a lot of whether in 5 years are we going to be satisfied with where we're at, and then it levels out. Like, when does this curve slow down? And I don't think it will, at least maybe in our lifetimes, just because we'll find ways to meet that maxima and continue to produce more, want more. And even then, like the AI agents and robots, and that's another world I think going into on the data side is the physical world is so much more complicated than a digital one in some ways. And then when you add that into the mix, I think it compounds on top of that. Other kind of questions that we get asked a lot, and we like to ask a lot of the founders, is if your company is successful, everything that you want to do over the next 10 years, you hit the milestones with ease and maybe even surprise yourself. What does StarCloud look like in 10 years? Everything that you want to have happen happens. Maybe as a company, but then we'll talk about
10
maybe
years,
the benefits of the world. Yeah, let's do, yeah, I mean, wherever you feel, if 10 years or maybe
20
20
years.
years, whichever. Okay, let's do 20. Yeah. Yeah.
20. So in 10 years, I think almost all new data centers will be being built in space. The one exception to that will be where you need extremely low latency, and many cities are built next to the sea. So I can imagine, Sam, that there's going to be people
There we
wanting
go.
to do what you're doing for the latency. But if for things that just want enormous amounts of raw power, I think in 10 years, almost all new data centers will be being built in space. That means that there will be a replacement rate over the next 10 years after that. And by 20 years, I would expect half of all data centers to be in space, or like at least. Then because data centers have, like a 20-year lifetime, it's going to take time to replace them. And then beyond that, we're building Dyson spheres and Matryoshka brains. Matryoshka brain is a Dyson sphere hooked up to as much compute as a star system can physically support.
Wow.
That's good. That's going to take probably about 100,000 years to build a Matryoshka brain.
1,000 years? Is that what you said?
Yeah. So if you surround a star with a swarm of solar panels,
exactly. Yeah.
yeah,
Well,
that's where we're heading. That's the future of StarCloud.
I was gonna say that you put that in the last page of your pitch deck. That's perfect. If you set Elon on it, maybe it'll be 1,000 years instead of 100,000. We'll have to wait and see. But do you have an idea what's the economy of that? Like, what does the economy look like of data centers in space then in 20 years? It's I mean, can you even project it? Like, does the line get like that gets too steep almost? I feel like.
I mean, I think almost in the end state, pretty much the entire physical economy will be data centers in space.
Yeah. And the robots
that's more than 20 years. Yeah. That's more than 20 years. That's probably more like hundreds of years. But I mean, if you take the current total data center revenue and add 10% per year out for 20 years, I think that's roughly the revenue potential of data centers in space.
Yeah,
that's talking tens of trillions of dollars.
Yep. And it's going to continue to be, I think, critical to national security for forever, for as long as we can project it. The other question that I get in
national
space,
and planetary security.
That's what I was going to say. It is. It could become a whole planetary type of thing as well. Yeah, especially as we think about climate and all the issues that we kind of have as a whole. The other question that I get, maybe it was one of those dumb questions that I get asked a lot and I don't have a good answer for, but maybe you've thought a lot more about it, is are we running out of space in space? Like, eventually, do we run out of space in space? Every now and then I see a picture and I'm like, that's a lot of satellites up there. Are they just not like running into each other like constantly? And then as you project forward and have all these data centers out there, like, do we run out of space in certain orbits? Like, what does that look? Is that a limit?
So those maps are incredibly misleading, and the reason is that each of those blobs is usually the width of California. They're literally the width of California. And you're talking about a satellite that's like this wide, that's represented as the width of California. Space is actually, there's a lot of space in space. I mean, if we actually start to run out of space, then we can just start putting stuff in a sun orbit or in the Lagrange points or in a lunar orbit. So there's basically limitless space in space. Much more space in space than there is space on Earth.
Absolutely. No, absolutely. And it's one of those ones I try to like look it up, and you're exactly right. The visuals don't do a very good job of showing it because, yeah, I see here are all the satellites, the SpaceX satellites. And I'm like, they're covering the whole Earth. There's no space anywhere. Like, what are we doing? And then, yeah, when you do a little bit of napkin math, you realize that there's a lot of space up there.
Yeah.
Sam, kind of thinking on your side, same question. You're projecting 20 years out. What does it look like for Network Ocean? But what does it look like, I think, as a whole back here on Earth, whether it's in the oceans or even on the terrestrial side? But yeah, specifically to your company as well.
Yeah, I mean, even 10 years, I think it gets really, really exciting. So, we're gonna have gigawatts of data center deployed, floating or underwater data centers deployed. Hopefully, that we get to the point where it starts to make a real dent in terms of the efficiency, average efficiency of the total kind of data center infrastructure globally. But what's really exciting after this is we're going to be starting to look at pushing out further from this kind of coastal infrastructure. A little bit further, we can look at probably start deploying or start at least looking at some of these nuclear-based options for power. And enabling us to go further out is actually huge because
Further off
I mean,
into
not
the
only
middle of the ocean. Yeah.
exactly. And you have, obviously a lot more space. You still get a ton of cooling, regulatory side. It's easier on some of those fronts. But really, like the main goal that I was talking about, like kind of at the beginning of our discussion, is that I want to push forward the capabilities of humanity in the oceans. And that really starts with, something where you can access grid level power out in the oceans. And there needs to be something that drives that demand. In other like major infrastructure build-outs in humanity's time scale, there's always been some kind of demand driver. And for the oceans, that could be data centers. So it'll be really interesting where you start to see other infrastructure being built on top of, our power and data center infrastructure out in the ocean. So, I mean, I'm super excited to see where that goes. It'll start with, transforming some current ocean industries, plenty of new unlocks that I'm very excited about and can talk about for forever. Yeah, I think essentially if you have grid level power out there, capabilities like drastically increase all the way to the point where you can have people living out there and really unlock, the 70% of their planet that we're basically just tapping the surface of. So that's what I'm excited about.
Give some examples of that. So it's almost like you're exactly right. If we start needing to build infrastructure out into the oceans, there's just other economies that'll be naturally built out from those. You said you have a bunch of those. What are some of the ones that you get excited about the most?
Yeah, I mean, with traditional industries, I mean, you can see like electrification of shipping. You can see, large scale agriculture, fishing, deep sea mining, basically just like large data collection and just huge macro engineering projects. What we're talking about, and you really have everything you need to have like a human colonies on the ocean. So I think there's some really interesting developments kind of across the board. Some of these other companies, but yeah, I'll stop there. But
This is the second time that Waterworld the movie has been brought up on this podcast. So that's the first thing I kind of think of is if we could eventually live out on the ocean, we'll have these like countries that are floating out there, so to speak. And maybe it starts with the data centers. Data centers are the pathway to living in the oceans.
yeah, I mean, there's in my view, a very, very clear path here. Kind of this golden path, right? So that we can have this first opportunity where we can build something at scale in the ocean that operates much better. And obviously, like they have stable, very, very high returns and massively scaled. More than any other industry on Earth. So using that, you can definitely build out the backbone of large scale power out in the ocean. And yeah, I mean, that's just like the moment where humanity finally actually unlocks the ocean. So I'm very excited for that.
Awesome. Last question before you kind of go into some CTAs and what you guys are working on or need help with. But what other companies that are either in your space or not, it could be completely unrelated industries or sectors, are you most excited about right now, not including yours or each other's companies? And Philip, maybe we start with you.
I'm super excited about humanoid robots.
Wow,
I
yeah.
invested in a company called Proception in the last batch. They've just got sued by Tesla because their engineer used to work there.
They were a Black
But,
Flag company as well. And what we're having
yeah,
them on the
I think
pod
I
here soon.
recommended them.
I think you did.
Oh, okay, amazing. He's absolutely awesome. That team is absolutely amazing. I went in to see them recently. So yeah, that's the thing I'm by far the most bullish about.
We had Ben over from K-Scale on a couple weeks ago as well, and talking about what they've done with K-Bot. I've said that the humanoid robots is probably the biggest thing that I've had my 180 thought on, where 2 years ago, if you would have said, when are people going to have robots in their homes or have robots doing mundane tasks like, coming in to fix like a drywall in your house or fix a leaky pipe or something like that. And I would have been like, like decades, if ever. People don't want that. Like, we don't want that at all. And now I'm like, it could be next year. Like, it's going to be so fast that
Yeah.
we're going to, the same way that you have a car, you're going to have a humanoid robot in your home. And obviously there's incredible layers to it in the commercial space, whether it's in space or in factories and in those. But I agree. I think that humanoid robots is going to be, that's why people are saying it could be one of the largest industries ever and it not even be close. And I could believe that.
Yeah.
So yeah, I think that's a really good one. So you mentioned any other specific companies that you think about in that space that you're excited about besides perception?
And that's the one I'm most excited about. Yeah, none really come to mind. So
Yeah, perfect. Sam, what about you? What are the industries, maybe even outside of the data center side, that you're really excited about right now?
Yeah, actually, a few guests that you had on your kind of ocean episode, I think like what Will is doing with Ulysses, what Poseidon is doing, like in terms of like unlocking, it's just like a very symbiotic relationship in terms of being able to unlock capabilities in the ocean. I think that's awesome, and there's like a real push that's starting to form. So that's really cool. Actually, on the data center side, I think there's tons of cool cooling technologies kind of across the stack that are happening, and I guess one that I'll highlight is Akash Systems. They're essentially making these like synthetic diamond cold plates, or like essentially the layer that sits right on top of the chip, like for direct to chip cooling. And it's this kind of like interface layer. This is heat spreader before you get to the cold plate itself, or the heat sink. And that's just like one single bottleneck in terms of like increasing heat capacity. Because I have a belief. I think there's a few pieces of example of this, but I think Jensen really wants to do more. He wants to increase the heat of these chips. He wants, all these like cooling and data center people to start, upping their game, and he's pushing that on a few different fronts. We really have to start improving this, and it's a little like call to action for the industry to start working on novel, new technologies across the stack. But what they're doing like kind of solves that one bottleneck, and then a new one will appear, and then we'll have someone attack that. Yeah, I mean, I think that's it's really exciting to see.
Yeah, the chip race is going to be a whole other category that's going to be fun to watch over the next decade as well. It's that's why it kind of feels like it's this really cool race across the board in energy efficiency, data center efficiency, chip efficiencies, all while AI is like compounding. So it's like all these things that are trying to bring the costs and infrastructure pieces down exponentially as fast as we can, while AI on the other side is like really trying to outdo those efficiencies as best as we can. My hope is that we just end up hopefully on the net positive side, but I think even if we're going to end up even, where we'll just continually, like, AI is going to grow and then we'll try to match that demand with efficiencies. We'll see how that projects over the next decade or so. But I agree on the ocean economy stuff. There's some fun stuff happening in the middle of the ocean, and we get a lot of startups that submit. We've had startups that have submitted like the cruise ship type of thing, where it's like, we're going to build cities or ecosystems. We had an accelerator propose that they're going to do a cruise ship. And so they're looking for funding to like start a cruise ship and then put a bunch of founders on it, sail around the world and do like an accelerator on the ocean, which could be kind of fun one too. But yeah, there's a lot of stuff. YC should do one on the ocean. Actually, Black Flag should, because it's a little more nautical themed.
Let me know how we can support. Maybe we'll be compete for you guys.
Yeah, I mean, honestly, as soon as the unlocks start happening, it'll be a free for all. So that's great. Anything else you guys want to cover? Any topics or things that on the data center side that we should bring into light?
I just wanted to say that it's awesome to chat with Sam again, because basically every single investor call I have, I get asked, why don't you build data centers under the sea? And so I have like an answer where I'm like, actually, when Microsoft did it, the reason they shut it down wasn't necessarily that they didn't have good results from it. Like, because my co-founder used to work at Microsoft, he said they actually produced some pretty good results from it. So it's a space that I think is super interesting and super cool. So yeah, it's cool to chat with Sam again.
Yeah, it's good. It's good to catch up. It's been a while since the batch.
And you guys are both in the Bay Area, right?
We're in Seattle, in Redmond.
Oh God, okay.
I see.
Yeah, so yeah,
We're
so
in SF.
Yeah, nice. So you're not going to run into each other in any sort of circumstance there. Are there like data center conventions that you can meet each other at and go to?
I'm sure. I'm sure.
Probably.
Yeah, absolutely.
Yeah, yeah. Well, great. Thank you again, guys, for jumping on. Before we hop off, I want to give each of you a little bit of a platform to share any needs that you have right now, hiring, announcements, anything like that. Philip, starting with you.
So we've got our first launch coming up in a few months. We'll likely go out for a raise after that towards the end of the year, and we'll look to bring on some more engineers. Not hiring right now. We'll keep the team as it is, but probably towards the end of the year, we'll be looking to bring on some more amazing engineers and sign some more customer contracts.
Amazing. Yeah, and we'll keep an eye out for the launch. What's the month, or do you have an exact date?
It's supposed to be mid-August, but we have launch provider dependent.
There you go.
We'll see. There's
Exactly.
an inkling it might get pushed back. We're ready. We've been ready since May, by the way. But
There
yeah.
you go. I was gonna say this isn't on your
Anyway.
side. This is it's the logistical hurdles of trying to ship something into space. Yeah. Sam, how about you?
Yeah. So I mean, the team is fully focused on getting our 200 kilowatt pilot unit out. So this is on the floating data center barge, and we'll scale up to tens of megawatts soon after that in terms of our deployment. So I mean, yeah, if there's any interest in having the most power, water, and cost efficient liquid cooled data center space on Earth, let us know. We're happy to get started with that and love the conversation.
Love it. Thanks again, guys. Thanks for being on. I'm sure that we'll try to do a follow-up episode, and then next year, hopefully, you guys can do some voting for the next Black Flag 100, and we'll see if we get a whole new lineup of folks. My guess is that you might have a good chance of being on it again. We'll see. Both of you guys are doing exciting stuff. So, thanks again for coming on, and we'll catch up soon.
Thanks so much for having us.
Awesome. Thanks a lot, Matt.
Thanks a lot.
Hoist the black flag high, let the cables hum. Code and cannon ready, futures beating like a drum. Charts are drawn in circuits, treasure maps and AI. We're sailing for the edge where bold ideas never die. Pirates only, all hands on deck.